Good morning or good afternoon, depending on where you are. My name is Kathy Kroll. I'm the Co-Director of Technology Transfer for the IBT ABC UTC at Florida International University. I'll be moderating today's webinar, and I'm assisted by Dr. Ankitha Arvan, our Research Assistant Professor at FIU, who'll be managing the web room. Our director is Dr. Atorad Azizanamini. Dr. Azizanamini sends his regards and regrets for not being able to join us today due to academic conflicts. We'd like to thank you and roughly 600 others registered sites for today on our 167th webinar in our monthly webinar series. Today's featured presentation is FastCast Bridges for Rural Transportation. We'll be starting with a few announcements and then moving on to the presentation that will last approximately 35 to 40 minutes. The presentation will be followed by a question and answer session. Thank you again to those who joined us for the 2024 Bridge Engineering Conference in Miami. This is a biannual event with the next conference scheduled for December 1st and 2nd in 2026. It will be again in Miami, Florida. Please mark your calendars. We have a few events to highlight from our industry partners. The first is the American Institute of Steel Construction National Steel Bridge Alliance, the AISC NSBA, will be hosting the Steel Conference that will include the World Steel Bridge Symposium. This event is in Louisville, Kentucky from April 2nd to the 4th. Registration is open. See the links on the screen for further information. Next, the American Composite Manufacturing Association, the ACMA, is hosting the Design Using Pultrusion Technology Conference in Chicago, Illinois from May 6th through the 8th. See the links on the screen for further information. Now for a few of our own events. The next monthly webinar will be on Thursday, March 20th from 1 to 2:15 Eastern. The featured presentation will be on sprayable UHPC. We'll be learning about a project undertaken by the Virginia DOT with the help of our own Florida International University. And we will be learning about the development of mobile capabilities to help make this technology readily available to all. Our next quarterly research seminar is scheduled for April 25th from 1 to 2:15 Eastern. The featured project is Transformative Bridge Asset Management using an Integrated Graph Network, RNN, approach. This seminar will be presented by our partners at the University of Georgia. Before we dive into our featured presentation, I'd like to go through a few housekeeping items. As many of you know, these webinars are recorded and posted on the IBT-ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation is provided in the Go-To dashboard on the right side of your screen. You can download these PDFs during the training session, and they will also be posted in the archives. Certificates of attendance are provided for these webinars. These certificates should be delivered directly to your email after the event. However, we've had some people reporting difficulties with receiving the email. So on the screen is a screenshot of our website. There's a red arrow that shows you where to go. So please know that you are able to get your certificate of attendance by clicking on that link. And then all you need to do is enter your email address and your certificates will be provided for all events you've attended, not just the most recent. So again, that's the location on our website where you can get some assistance with certificates. If you still have difficulties, please contact us at the links on the website. Lastly, this presentation will be followed by approximately 15 minutes of question and answer. So please enter your questions, any questions that you have, in the question box on the Go-To webinar dashboard. With that, we'll begin our featured presentation. If the presenters would like to turn their cameras on, we welcome Andy Vanneman, President of Premier Steel, David Ford with the Department of Transportation for the Muskogee Nation, and Jim Sally, Director of Transportation, Roads, and Bridges for the Choctaw Nation, as well as Christopher Swanson, Principal at DCI Engineers. Thank you all for sharing your time and expertise with us today. With that, we'll turn the screen controls over to Andy. And Andy, if you could mention the presenter who's not able to join us today. I didn't work that in.
That's no problem. Thank you, Kathy. No, David Ford with the Muskogee Nation, Oklahoma got hit pretty hard with a deep freeze on some heavy ice, and he's going to be unable to join us for the presentation today. Chris Swanson's with DCI Engineers. He's going to join us. He's our structural engineer. And Jim Salee with the Choctaw Nation, who is an asset holder of multiple Premier Steel fast cast products, is going to join us and present one of the bridges that he has. And I'm going to have to minimize some stuff. Excuse me. So our presentation overview is I want to introduce and tell everyone the story of the fast cast bridge. I want to talk through the fast cast structural engineering and turn that over to Chris to allow him to expound on that. And then we had two asset holders and their real world applications. We're going to have Jim Slee with the Choctaw Nation DOT department go through the Kennedy Road story. And because David Ford is not going to be able to be here, I'm going to take you through the Muskogee Nation Old Morris Highway that also won the WBC Innovative Bridge Construction Project of the Year, less than 10 million. And then we're going to pull out a crystal ball and try to talk about where we're going forward with the fast cast bridge. So Premier Steel Services was established in 2004. We're an AISC certified fabricator that specializes in multi-story construction and composite frame construction all across the United States. We're also NQAL1 compliant and have been at some of the nuclear labs working in fabrication for the duration of our existence. We've got quite a bit of federal government experience in the national labs, commercial, and tribal projects nationwide. And we're a growing company, started out in 43,000 square foot, and we're up to 120,000 square foot facility with approximately 40 plus employees. Chris, you want to introduce DCI Engineers?
Yes, thank you, Andy. Yeah, DCI Engineers, we are established in 1988. We were founded in Seattle. We now have a national footprint with offices across the United States. We are a structural and civil engineering firm doing services throughout. And we do also niche services of, as you say, heavy industrial right-of-way sustainability. We do have both building and bridge division.
Okay, perfect. So the fast cast bridge story, being a fabricator, we had some flood events in the spring of 2019 in Oklahoma, and a cattleman, friend of mine, much to my senior, we were going to town to have breakfast, and bridge was out, and he was like, Andy, you build multi-story buildings all over the country. Why can't you build a bridge that'll go in quickly? So we started at that point with taking our expertise of composite structures and worked with DCI Engineers, and our first fast cast bridge was installed in June of 2019. And now we have 35 plus fast cast bridges installed. We've installed them in Oklahoma, Texas, Alaska, Washington, and for future planning, we're already working with Kentucky, New Mexico, Arizona, Arkansas, and New York currently. We did receive our registered trademarks and our patent, which allows the sole sourcing, whether it's been tribal, municipal, or county. All our customers have used our patent to sole source the actual product from Premier. And I mentioned earlier that we did win the award at the WBEC. We're fabricated just like we do a multi-story building with our bridge components, and we load the trucks just like we build buildings. So we've had all of our bridges have been built and installed in 1 to 2 days and poured under 3 days. A lot have been done in 1 day. So what the fast cast bridge is, in layman's terms, it would be a flying steel form system that stays in place where you get the speed and performance of steel and the tolerances of steel and the performance of concrete together. We do partially precast the tub girders to eliminate the necessity of shoring, which the walls will support. Because we're modular in our design, we can add bike and pedestrian lanes. We can add varying edge conditions, water gaps. We've actually partnered with Green Frog Solar, and now we're offering solar street lighting packages. And one of the unique things, we're able to do head walls or wing walls, and angles don't really bother us. So we're able to, it's just a degree on a press brake. Our steel outer shell basically protects the concrete from any environmental damage, including spalling. We're coated with a 20+ mil polyamine epoxy, providing approximately 30 years of corrosion resistance, but you can go in and touch it up. It is an immersion paint system, which means it would cure underwater, and it's meant to be underwater. We have multiple additives. It's actually a Sigma Shield 880 PPG coating, and we can put anti-graffiti additives, and we're able to cover a variety of paint colors for different different counties, states, etc. Chris, you want to take the structural engineering?
Yeah, no, thank you, Andy. So the bridge design that Andy and we came up with was, again, we tried to do it against a modular approach. The whole idea was speed and get this in and out and fast and design. So designing that, you need to modularize your design. And we came up with an idea of coming up for spans of 20, 30, 40, 50, and 60. These are all single foot spans that are, simple spans that we're going to do. And we try to keep them all the same, or try to fit everything within a box that we do. And again, the essence is speed. Everything, bridge decks and beams, are using conventional mild reinforced, so we're not using any pre-stressing. We don't have to worry about any of that, and we try to keep it that way, again, to make things simple, using regular materials that we currently have. Bridges are designed for various loading categories. Every bridge, every county, every state, every jurisdiction has their own requirement, and we have to meet that. We have a base design where we use just AASHTO LRFD HL 93 loading and regular vehicle loads, and then we can adapt that to whatever specialty need you need, whether it's added superficial dead load or added specialty trucks, permit vehicles, etc. As Andy was saying, we partially precast the tub girder, again, to eliminate any temporary shoring, and again, speed of construction. Another idea is that we go through all bolted connections. So I always do the same as an engineer. A lot of engineers out here, keep it simple. If you keep it simple, it goes much easier. It's not that it's complex, but keep it simple. Again, modular design. Now, walls that we do, it is kind of the base design. We have a bridge class box culvert that you see. So we are integrating the walls and the bottom that we use. Now, the difference on the walls that we have, they are a composite wall. We do not use internal rebar, bonded rebar in that. We do use the composite steel plates and infill it only with steel concrete, and dowel it to both the beams and the foundation. We follow design guides that, steel plate shear walls have been used in buildings and nuclear facilities for years. And we follow the AISC design guide for modular steel plate composite shear walls. So all of these things taken in together, again, improve the speed, time, and efficiency that you can to put a bridge together. Andy, you want to go ahead?
Yeah, and the one thing, Chris, that you didn't cover, we do have our standard designs with wall heights retained up to 25 feet, but we also offer multi-spans, which we've done multiple bridges at multi-spans up to the 60-foot single span.
Yes, thank you. Yeah, we do add the intermittent abutment that we do to go for longer spans when needed. And then you also have the bottomless bridge. We are doing ones that do not have a base.
And Jim, I'm going to turn this part of the presentation over to Jim Salee. He is head of the Choctaw Nation Roads Department, which is their internal DOT. So Jim, you want to go ahead and tell them about the Kennedy Road?
Yes, sir. Halito, that is hello in Choctaw language. I'm the director of Road and Bridge Transportation Department for the Choctaw Nation of Oklahoma. The bridge you're looking at here on the screen, this is located in one of our more mountainous areas of our reservation. It's located in northern Leflore County. It is a tributary to Wild Horse Creek. This bridge here, the original bridge was built around 1930 and was on the brink of being condemned. This road was a school bus route, access to 2 rock quarries and many cattle ranches. When we went up and inspected the bridge and seen the condition of it, we immediately acted with our tribal transportation funds. We were able to go ahead and start progress on getting the bridge design built. We hired a guy engineering to do all the civil engineering work on the project. And once the hydraulics was done, we turned it over to Premier Steel to get us a design and an estimate back. And we actually signed the contract around the 1st of August on this project in 2023. We started moving forward. We got our general contractor on board. He happened to be a local contractor that actually was the winning bid. And we worked with the county commissioners hand in hand, and we got this thing designed. And Andy and them with Premier, they had it designed within a couple of weeks. We turned the design back over to our civil engineer. He incorporated the approaches back into the project, and we began construction. The contractor that we had on board for this project, he had never put one of these together. He was really excited about the project. He wanted to try this, and we put this thing together. Once we got the fittings poured in place by the contractor, Premier Steel delivered the bridge. We actually put the entire bridge together in a day and a half, and then we poured all the abutments, the head walls, and the deck all in one day. Went together really fast, and we had to, as you can see, we had to deal with water constantly through the project. Here's the designs that we got, the plans that we received from Premier Steel. As you can see, they're very simple. As Chris was saying, keep it simple, and it'll speed up the time. It did speed up the whole project. by doing this. And we actually cut our construction time by half of what it would on a normal cast in place bridge. As you can see in the middle screen here, we worked with Andy, the landowner. He wanted a water gap, and they designed this water gap and installed it on the bridge. After we got the bridge poured in place, got it set in place, our cattlemen in the area have all come by and looked at this, and they just think this is one of the greatest things that ever happened. They like this design. Matter of fact, I think they've even talked to the county about doing something like this on existing bridges. The contractor, once he got finished with this, first thing he said to me was, "We want to do more of these." And so we're working on trying to get more money, more funding to do more bridges in our reservation area. And Premier Steel, I'll be honest, we looked at other bridge packages, but they just didn't fit the need that Premier Steel provided to us. We're very satisfied with it. We're satisfied with the time of savings, because it saves down on detour. The detour around this project was about 14 miles. And we also, we've got a couple of rock quarries that semis come across this bridge on a daily basis. It's a very rural area, but where the county was very satisfied with everything. The ranchers and farmers in the area were very satisfied with it. And it's a good quality, good looking bridge. We're very satisfied with the coating. I could go on and on of just how well this thing has performed for us, and we're doing more projects with it, and we think it's a great product, and like I said, we will be using more. Right now, we've got a couple of the head walls sitting on the ground waiting to be installed that they designed for us. Back to you, Andy.
All right. Thanks, Jim. And like I said, David Ford, and if anybody has any questions for Jim specifically about that project in the Q&A, we can get back to that. I'm going to talk through the Old Morris Highway story. We had some flood events that washed out multi-culvert structure within the Muskogee Nation reservation boundaries. The Muskogee Nation has bought in excess of 9 fast cast bridges from me at this time. They contacted us and asked us to work with their civil engineer to replace what was a failed multi-culvert project. We ended up working with Cross Timbers Consulting, and they designed a bridge class box culvert, 42-foot clear span on about a 30-foot angle with 40-foot wide roadway with TL4 crash barriers on the outside that they were planning on future road expansion. The entire project was beyond the foundations, was built by their selected contractor. Once they bid it out, it was put together and poured in 2.5 days. You can see a general set of the design documents and the SKUs that we were able to do with the fast cast bridge. And we were able to accommodate the different angles of the abutment protection wing walls at each end. Kind of shows some of our walkways, and unfortunately the contractor was moving so fast he didn't put all the walk boards up he should have. And it shows how he forms in the scour elements or the curtain walls. And that was the Old Morris Highway story. I'm going to talk about the fast cast product suite, which in this, as Chris alluded to earlier, not only do we build bridge class box culverts, but we also build bottomless bridges. Jim was talking about our fast cast culvert ends. We're able for scour mitigation to accommodate from 12-inch culverts to 12-foot culverts. We can also accommodate arch structures, ovals, squares, etc., to have a cast in place culvert in that allows for scour mitigation. We also have the pedestrian guards, or as an engineer told me out of Kentucky, a refrigerator guard. And I asked him, I said, what's a refrigerator guard? And he said, that's those pipes they put on the end, so when the creeks get full, the refrigerators float up and land in the middle of the road. We do have the ability to add different elements to our bridges. As Jim talked about, water gaps, we're able to put pedestrian lanes and rails on, solar lighting packages, different edge conditions. We're pretty agile at being able to meet our customers' needs and the local design professionals at what they need to accommodate for their design. Kind of that crystal ball we're talking about and where we're going. Premier Steel has developed a pricing application. We're at Gen 2 in it, and because we're steel and almost a commodity, it's how tall, how wide the roadway is, what the length of span is, and how many miles it is from Tulsa, Oklahoma, is how we price and generate proposals. It takes us approximately 2 to 3 days to provide a budget and a set of design documents for the local design professionals to work into their designs. We are moving towards, in that crystal ball, a graphic user interface sometime in the future where we'll be able to credential engineering groups that they can go in, select a bridge type, fill out some dimensions, request a proposal, and get full-blown design documents and a proposal back to help make their jobs more efficient and easier. So what we wanted to do, and we're seeing this, to take an innovative design approach. In other words, let's not reinvent the wheel each time, and let's make our designs very agile to be able to adapt and change for the different environments, the different state requirements, county requirements, municipal requirements, and provide tools to the local design professionals to make it work faster. As we've all seen, skilled labor challenges in the field are becoming more and more increasingly difficult to find the skilled labor. And the more we can do in a quality control plan environment and make it easier in the field, the safer, which is probably the highest priority, the safer and faster it works, and reducing that traffic change or detours is a huge, huge cost, but more on a safety cost than anything else. And our cost efficiency, can't speak to a per square foot cost, but I can say that the people that we are dealing with, if I say our product is a little more product per product than a cast in place or precast, but we're becoming more cost effective by the amount of time that our contractors are on site, moving back and forth, in and out, and we're minimizing disruptions, has been what our customers keep coming back to us for. So a couple of things I want to get to before I turn it to Paul for the questions. There's a QR code. If you want to learn more about the fast cast bridges, you can go to our website. take a look at the actual time lapses of the projects going together. Or you can also go to YouTube and search for Premier Steel Services, and you can see a variety of our products being put in. And with that, I'll turn it to Paul for the questions.
Super. Thank you very much. That's a great presentation. Thank you to Andy, Chris, and Jim. We have had a number of questions that came in both before and during the presentation. Paul Lyles, the former Georgia State Bridge Engineer, will start the question and answer session, and he will be joined by Jugesh Kapoor.
Okay. Hey, Jugesh. Andy and Chris, you want to turn your cameras on?
Yes, sir.
Okay. All right, good. We do have some questions that came in beforehand, and we have some that have come in during your presentation. So we'll go ahead and get into them. These first questions I'm going to ask came in beforehand. And the first one here is, do fast cast bridges have a multi-cell option, or is every crossing just a single span? You mentioned that in your presentation that you could do multiples, but go ahead and talk about that for a minute.
Well, we actually have a multi-cell built out back. We can go up to 3 simple spans under our current design. And that's the largest that we've looked at, is potentially 3 60 footers going up to 180. The one we have built that's going to go in, and I'm actually planning on live streaming that, Paul, is for the Cherokee Nation. It's a 40-foot wide roadway, 20, 40, 20 foot in span on about a 30-degree skew with 4 different angles on wing walls.
Okay. Here's another one that came in beforehand. Is 42 feet the longest span, or is it possible to use this concept for longer bridges? You mentioned you had some up to 60 feet. What's the maximum you could do?
Simple span 60 feet is where we find ourselves to be very cost effective. Longer than that, we lose that cost effectiveness.
Okay. Then another one that came in beforehand is, what's the maximum skew for a fast cast bridge? Your Kennedy Road thing was skewed at 30 degrees, you said. So anyway, go ahead and tell us, what's the maximum you can do?
Well, we've done up to 60, but I don't know that we can't do more. I'd have to defer to the structural engineer.
Yeah, I think it all depends. There's so many factors on it. I would say 60 is probably about the farthest you'd want to go where it makes sense.
Okay, that's fine. And then another question here that came in beforehand: were any of the fast cast bridges designed for high seismic areas?
Chris?
Yeah, we have designed the simple spans up in Washington, which is it's not high, it's pretty moderate. We haven't done any in California for Caltrans yet. So it can, if it need to.
Okay. Simple spans are usually pretty good for seismic.
Yeah. There's not too much on a simple span for seismic
okay.
that you have to do with.
All right. Then the next thing is, how are the bridge barriers designed? You mentioned TL4, and you want to comment on the bridge barriers?
Yeah, typically we try to use a already pre-engineered or pre-designed barrier. Usually, a lot of TxDOT has a lot of different types that we can pick from TL3, TL4. The TL4s are usually the barrier wall that you do. It's just a wall, so it's pretty straightforward. TL3s use the W rail with the pins on it. I'm sorry, the supports at it every like 3 to 6 feet.
Okay. There was another question that came in during the presentation that along those lines, and it said, have the head walls or integral barrier been crash tested? Sounds like you're using the ones that are already pre-approved that have been crash tested, really.
Right. I'll go with the easy way out. Exactly. Let's use the ones that are there.
Okay, that's fine. Let's look at some questions here that came in on durability. We have a number of these, and they came in beforehand. The first one says, in Vermont, we have many mountainous streams with heavy sediment transport. How would these structures and coatings stand up to these conditions?
Chris, do you want to take that?
Yeah, so the polyamide epoxy that we use does come with a corrosion and impact resistance to it. They follow an ISO standard, the ISO 12944, which is for marine environments. We can provide you the impact resistance, which is really what it needs to be, and it's based on your mill thickness.
Okay. Then the next one here, and this came in beforehand, is what is the anticipated lifespan of the bridges?
Well, in Kentucky, going through the approval process, we've signed affidavits for 75 plus years. It's going to be, Chris, and you'll, from an engineering perspective, it's 75 to 100 years plus.
Yeah, there's a lot of variables on it, but 75 is an easy number to, if you want to pick a lifespan.
Okay, now you did mention that on the coating, though, you had a 30 plus years or something like that. Is it going to have to be reapplied or something at that time?
And I wanted to add too, one of the reasons we picked Spectrum Painting and the PPG coating system, when we started down this bridge, we wanted a durable paint. So we picked what they paint offshore rigs with. And what's really unique about it is during the touch-up, it's not required to be blasted off or reabraded. You can power wash it and touch it up by hand and reapply it without a heavy skill set to that, and it cures underwater. So that's the reason we selected that paint system, and it's widely available across the country.
Okay, now your structural steel, is it just, it's not a weathering steel or anything, is it? Okay.
No, sir.
Okay. All right, that's fine. Here's another interesting question that came in beforehand on durability, excuse me, on, let me go back to another, okay, you mentioned you mentioned the corrosion resistance, so that's fat and good. The general questions of structures that have been completed, do you have a breakdown by states of where they are located? Now you mentioned that in slide 4. You read off the ones. And the other part of this question is, do you have locations for bridge projects that are in the planning stages?
To answer that, we have bridges right now in Oklahoma, Texas, Alaska, and Washington. Do I have locations exact? No, because the design professionals have those. They just give me where it's going close to. But we are working with Kentucky, New Mexico, Arizona, Arkansas, and New York. And a matter of fact, we'll be in New York meeting some folks next week on projects potentially coming up.
Okay.
And most of the bridges, Paul, have been in Oklahoma. I've got 2 in Texas, 1 in Washington, 1 in Alaska.
Okay. And here's another one that says, do any fast cast bridge projects been completed or are under construction in Maryland, Pennsylvania, or Delaware?
Not yet, but we're hoping pretty quick.
Looking for the opportunity anytime.
Tell them to contact you and you'll work with them.
We can make it happen.
Okay. Then the next questions we get into are construction questions. And we have, what is the anticipated duration of closure for replacement of a typical bridge?
Well, and that depends on the contractor and the asset holder. Paul, we've had them done as fast as almost 3.5 days with special additives on a small structure to reopen a heavy haul road. I would say typically within 3 weeks, demo, build, redo would be almost a planned anticipated time. They can be done much faster. We've done them up to 7 days to reopen with some high hourly additives in the concrete.
And I might add to that, one thing we didn't bring on, or I didn't bring up, was the foundation system. We do integrate. Foundations are designed separately typically. I mean, most often we're usually a spread footing because they're short span bridges. They're not needed to have some, and the soils are decent. However, if you do need drilled piers or a deeper foundation, that could take longer to install the foundation.
Okay. What would you use? Would you use piles? Is that what you're
Piles,
thinking?
piers, yeah, auger cast, whatever.
Drill shaft. Okay.
Yep.
All right. Then the next question here on construction is, this came in beforehand. Is calcium chloride added to concrete to accelerate the curing?
We've done high earlies if we need to. We're not using high strength concrete, so it's not really a necessary evil, because I think the strength we're already at is only at 4,000 or 5,000 PSI.
4,000, Chris.
But you
4,000.
don't add calcium chloride to it.
No, I don't typically think they do.
Okay, that's fine. We had a question here on what is, going over the cost questions. We have, what is the square foot cost for the fast cast bridges? And Andy, you mentioned you really didn't have a square foot cost, but you want to talk a little bit more on the cost?
Well, it's not like we're doing just a bridge deck. Our abutments are the bulk and majority of the cost of the fast cast bridge. So it's how tall and how wide. Have an upcoming project in Texas that is actually a 20-foot span. It's 10 foot tall, but it's a 115-foot wide roadway. Each bridge is unique and different. It doesn't take very long to price it. Within about 10 minutes, I can give you a price and a budget if you can tell me how far it is.
Okay.
And
Then
I'm going to defer one more. Why don't we let Jim Salee talk about that, because he's somebody that's actually studied the cost versus what he had. Jim, you mind taking that?
Yeah, I'll be glad to. On the Kennedy Bridge, we looked at some options of doing the cast in place bridge and got some estimates done on that. Typically, we did not save any money by going with a fast cast bridge, but where we saved our cost in the entire project was time. By the time you save money on your construction signage, you save money on labor, you save the GC fees, you save money on that, because the project we did on the Kennedy Bridge, we actually broke ground around the 1st of October, and we had a substantial completion on January the 19th, the following year. So that included nearly 800 feet of approaches. We actually raised the bridge from the height of the bridge off the creek bed, but prior to construction, we were on the old bridge was like 9 feet, and we expanded this one up to, I think it was like 11 feet. So we had to, and plus we also realigned the road. We moved the road over about 15 foot to straighten the road out. So where we saved money on this project was time. We literally cut our construction cost in half because of the time frame. And so that's where our big savings was. Same way on our precast, on the precast culvert end sections that they provided to us. It saved us about $10,000 just on the precast culvert ends, because of we don't have to set any forms. The steel is the form. You set it in place, you pour it full of concrete, and you're done.
Thanks, Jim.
Yeah. Okay, we'll get a couple questions here that came in during your presentation that I want to pick up, and then I'm going to turn it on over to Jugash, I think. Do the designs include sacrificial thickness of the steel walls to account for corrosion and section loss?
No, we don't count for any sacrificial loss on that with the paint and epoxy. The forms for the tub girders, that is a sacrificial steel. So it's two different parts. That is completely sacrificial, but the walls themselves are not.
Okay. The next one here is, did the concrete pours use a rapid set concrete if they're opened in only 3 or 4 days?
Paul,
You talked on
to
that
answer
earlier.
that, yeah, we've used high early additives, and it comes back to once we get breaks. One of the things with the fast cast wall system, and because of the strength of the steel walls, we only require 50% strength before we start backfilling and compacting on our abutment walls. But for travel, we have to get to full strength.
Okay. We got a number of questions left. Jugash, do you want to come on and pick some of these up?
Paul, I am not seeing any questions in my chat
Oh,
box.
I'm sorry, Jugash. I think I know what's happened. You haven't been lined up. I'll go ahead and pick them up. That's fine. The first one here is once again on the concrete. Does fast cast bridge utilize self-consolidating concrete? And what is the time frame? Go ahead and first of all ask about fast cast concrete.
Well,
yeah.
Absolutely, I recommend, especially with the taller abutment walls, using an SCC concrete to ensure that you get proper consolidation. It is a means and methods for the contractor. I personally don't want to work that hard and put the vibrator and stinger down that big a hole, but hey, it's each person's choice.
Okay.
I think we recommend it on the walls. It's a recommendation, absolutely.
Okay. What is the time frame from completion to open to traffic for full strength of structure? How long can you let the concrete before you put traffic on it?
We have had it done in 3 days with concrete additives. Standard is going to be 21 to 28 days.
Okay. All right. Another question came up about the crash testing of the rails. You mentioned that, and then does it meet FHWA standards is the other part of the question.
Yeah, I mean, well, I'm trying to pick something that's already been approved. So that would be yes, I guess, in that sense. We're not trying anything new.
Okay. And then the next one, this is good. Is the steel recycled or imported or other origin matters? Is it Buy America, I think is the question.
It is American. Yes. And all steel is recycled at some point.
Yeah, I know everybody uses it. They recycle everything. They'll recycle a nail if they get a chance. But anyway, the melt it down and recast it. But is in the Buy America, that's the thing. If you're going to use federal funds, that's a requirement in federal funds. So you said there's no problem there. Okay, we have one more here that's come in. Anybody else got some more questions out there? You can send them in. Any cracking projected in the maintenance levels? You want to comment on that in the steel with the any cracking
Chris,
of your
I'm going to
concrete?
let you.
Yeah, I mean, I think inside the walls, no. I mean, we're not going to see cracking because it's pretty much within the concrete walls or in the steel walls shell. I think as every bridge deck, you're going to have maintenance and cracking over time, depending on what you get. So a crack maintenance procedure you want to have regardless. We don't design it as a crack concrete section on there, and we haven't seen, as a normal wear and tear bridge deck, that's what you're going to get for cracking.
Okay, that's
Hey,
good.
I'd like to add something to that.
Jim?
With the way these are designed and the deck pans that are supplied with Premier Steel, on a conventional cast in place bridge, you don't have anything to hold the concrete once it's cured underneath. These here, they have the galvanized deck pans that hold the concrete. So if we've seen a lot of here in Oklahoma, we've seen a lot of these older bridges when they start cracking, you'll start having concrete falling from underneath. And with the deck pans that are supplied with the galvanized deck pans that are supplied with the bridge, that won't happen. It'll if you do have a crack or something in the concrete, the galvanized deck pans will hold that concrete in place and keep it from falling through the bridge.
Okay. Here's another one that just came in. Is there internal rebar in the abutment wing walls?
No. The only internal rebar we have is at the connections for the bridge girders and then at the foundation. But between that, it's just the external steel, composite wall.
The shell that you're talking about.
The shell, correct.
Okay.
Which is about 10 times stronger than a regular internal reinforced concrete wall.
Okay. Yeah, what was the spec you mentioned that on? You said they were used in the nuclear industry and other things.
Yeah, so the design guide that you can follow, AISC has a design guide 32, modular steel plate composite walls, and it's used for safety rated nuclear facilities. We've adapted that to bridge.
Okay. That is most of the questions we have, and y'all have been real good with your answers. So Kathy, do you wanna come back?
Great. Thank you, Paul. I actually had one question. In the presentations, you had some of the design drawings, just screenshots of the design drawings. Would it be possible for us to get PDFs of those design drawings, and we'll include them with the archives? I think that would be something people would really appreciate.
Yes, ma'am, and I believe I'm going to flip back. Oops. Yeah, these are the actual. Now I didn't put the stamp drawings, but these are the actual design documents for Old Morris Highway and Kennedy Road.
That'd be perfect.
Yes, ma'am, and they're part of that presentation.
Wonderful. So for the attendees, know that we'll go ahead and get PDFs of those design drawings and include those with the archives. Another question for Andy. Tell us about the World Bridge Engineering Award.
Well, that kind of humbling. Miss Kathy, and you're kind of part of the story. New Mexico DOT had referred us to you, and Dr. Aderod had called us and had interviewed us and talked through about what we're doing here in Oklahoma and how within 5 years and 2 years were COVID and kind of slowed the process down pretty heavy, how we had gotten the amount of traction we had gotten across the country. And Dr. Aderod asked me if I'd present down there, and I said, sure. And I thought he was throwing me a bone. He said, well, would you present for a call to award? And I thought he was throwing us a bone just because we were going to go down and present in Miami. And we ended up winning that award. And after hearing about how the DOTs and how that process of how they voted on it, quite a humbling experience. And it's been very positive for us since.
Great. Well, super. Well, congratulations on that award. It's really well deserved. It was the Morrison Highway project, correct?
Yes, ma'am.
Wonderful. All right. Well, congratulations on that. And thank you very much to the presenters for sharing your time and expertise with us today. It was a very interesting presentation. And thank you to Paul for helping out with the question and answers. With that, we thank you all for joining us today, and the webinar is now concluded.